That's a nice application of complex numbers. But complex numbers weren't always around, and people had a little difficulty with them when they were first invented. So let's take a look at two different problems. X squared equals 25 and x squared equals negative 25. Now there's a couple ways you can solve this one, but in anticipation of the stuff that we're going to do in chapter 10, let me suggest we solve this one this way. We're looking for numbers that we can square to get 25. So one way to solve would be to take the square root on both sides. And that's okay. But on the right-hand side, you're going to have to take plus and minus the square root, because there's really two different things that I can square to get 25. You can square 5, and that'll give you 25, but you can also square a negative 5. So there's really two solutions there. So, okay. And this is called the square root property. Like I said, we'll investigate that more in chapter 10. And while I'm working on this, let me pass out a handout. But the second equation gave mathematicians fits for centuries. They just didn't like this. Although eventually what happened was mathematicians like Girolamo Cardano from Italy in the 15th century started playing around with using the square root of a negative number. So yeah, we're going to take the square root on both sides, and sure, we're going to play around with, or we're going to remember the plus or minus. But he started playing around with the idea of doing something with the square root of negative 1. And what happened was that in using this thing that they didn't even think existed, they could actually get the solution to problems only this way. And they started to think, well, maybe it has some use. But it literally took centuries before people accepted this idea of working with the square root of negative 1. Now, what we've come to use and do in our modern notation is we've come to make a definition for this. The square root of negative 1 is called I. And it's probably called I because I is the first letter in imaginary. And they thought these things were imaginary. It's ridiculous. You can't do that. It's imaginary. And the name stuck. It was certainly used pejoratively at first, but it stuck. And so you get something like this. You get 5i is the square root of negative 25. So that means for us that our days of writing narn are gone. We can now actually put something here as opposed to not a real number, which is what we had for a while in chapter 8. Okay, so more generally speaking, we're going to look at what are called complex numbers. Now this is the imaginary number. Complex numbers look like this. We could have a number like, well, they're going to generally be of the form a plus bi, where a and b are real numbers, and I'm grandfather claused in using this in, before it's corrupted as hashtag, it used to be number, or the pound sign, real numbers, and I equals the square root of negative 1. So some examples. You could have 7 minus 3i. You could have 5 plus 4i. You could have negative pi plus square root of 2 times I. You could have 8 plus 0i. Now a lot of times people will just write that as 8. But what this is showing you is that the real numbers that you're familiar with are really a special case of complex numbers where this imaginary part is 0. You could also have something that's wholly imaginary, negative 9i, for instance. And you could, if you wanted to, write it as 0 minus 9i. That's fine as well. But these are all examples of complex numbers. You have what's called a real part. That's this number here. That's your real part. And then, of course, the other part is your imaginary part. And that's going to be this part right there. Oops. And generally speaking, we're just going to, when we ask for the real and imaginary part, we're probably just looking for the coefficients, that is the a and the b. You don't have to put the I in as part of that. So those are your real and complex numbers. Here's a real number, it's a special case of a complex number, etc. Now it's these numbers that made up those cool fractal images that I was showing you earlier. And just to kind of fill in the blank here for you on your homework problems, for the complex number 4 plus 5i, you call 4 is the real part, and 5 is the imaginary part. It's not 5i, it's just the 5. 5 is the imaginary part. And one more little bit of trivia or notation here for us. If you have 5 plus 6i and 5 minus 6i, these are called complex conjugates. I'll put that in there in a second here. Complex conjugates. There's a reason to kind of study these and look at these. They're going to be pretty handy for us for certain problems. But let's start out by playing around with some of these things down here. And in particular, how would you clean up something like this? Well, what I would do with that is I would split off your I term. I is going to be the square root of -1. The reason that's so handy is because with this definition, what's going to happen if I square both sides? On the left-hand side, I'll get I squared. What do you suppose I'll get on the right-hand side? What do you get when you square this? Close. -1. So this is something that you can square to get a negative number. And that's why it's so useful for us here. So square root of 25 times square root of -1, that becomes our 5i. Okay, great. Let's look at square root of -13. We're going to do the same thing here that we did just a moment ago. We're going to write that as square root of 13 times square root of -1. Now there's not much that you can do with the square root of 13. So I'll just leave it. But I can rewrite this as a square root of 13 times I. Interesting. Now, I will share with you one other thing here. A lot of times I won't write it like that. A lot of times I'll write it as I times the square root of 13. And the reason I write it with the I out in front, even though a lot of people won't do that, is because I don't want it to get confused with the square root of 13i. You will not, in this course, take the square root of I. That's something you can do, but it's something for a higher level course. It's not something we're going to worry about here. So, and the reason I put the I out front is because there's a temptation, or some people get sloppy and they'll draw that square root over the I, at which point these two things are no longer equal. All right, let's keep rolling. Let me squeeze in another one here. Square root of -12. Well, I'm going to do it this way. I'm going to break it up into 3 radicals. The first one that I'll do is actually the one that I put in the middle. I'm going to put square root of -1 there. Now we've taken care of our negative part. Let's work on the other 2 parts. Remember when we were working with this stuff earlier in section 9.6 and things like that. You want to break up the number 12 into two parts. The part that is a nice, easy square root, and then what's left over, right? The leftovers go to the dog. All right, I got 2 dogs, so give them good leftovers. How can I break up 12? What 2 numbers can I use to do for 12? 3 and 4. Which one's going to go out in front? 4 is going to go out in front, and 3 is going to go here. 3 is kind of like the leftovers. But 4 goes out in front because that's a nice perfect square. We can take the square root of 4, right? What's the square root of 4? 2. So this is going to simplify down to 2. What's the square root of negative 1 going to simplify to? I. Square root of 3. Wow. Well, that's cool. Now, do you guys have a graphing calculator today? If you don't, I think you know the drill. We're going to check this. We're going to check this number out on our graphing calculators. So come on up and get one if you need one. I'm going to clean this up while you do. Thank you. Thank you. All right, so these are numbers that I can square. I should be able to square this and get 25, for instance, right? I mean, that's what this says. When you take the square root of this, you get 5i. So let's check that out. Let's put in a 5. And if you look hard enough on your graphing calculator, you'll actually find an I on it. So where's the I? Well, it's right above the decimal. What do you think I got to do to get that number there, to get the I? Well, it's in blue, and I've got a blue key up here. Yeah, so the second key. Second, and then that. And you press enter, and nothing happens. But here's where we can do some magic. You can square that number. So once you've pressed enter, hit the square key. What should I get when I square this? Anyone? Negative 25. And there you go. In fact, they put it in nice complex form. It did negative 25 plus 0i. And that's fine. 0i is just 0. Plus negative 25 is still negative 25. So, wow, it works. How about the one down below that? What if I did 2 times I and then the square root of 3? Now, if I just type this in, I'm just going to get a really ugly number. It's probably going to be about 3.464, I'm guessing. That was a pretty good guess, huh? Not bad. I'm impressed. But the point that I want to do is I want to square that and see what I should get. I should get negative 12. Beautiful. You get negative 12. Nice. Okay, let's keep going. Square root of, or negative the square root of negative 8. So I'm going to have a negative out in front. Break up square root of negative 8 into 3 parts. Let's start with the easy part. I'm going to put this part here in the middle. What do you think I'm going to put in the middle? Minus 1. The reason I'm putting it there is because I don't want that I at the end. I don't want it to all of a sudden migrate underneath the square root. It should stay out of the square root, and when you put it in front, it's going to stay out of the square root. How are we going to break up the square root of 8 then? What into what? 4 and 2. Nice. Overall, what's that going to look like? How does that simplify? Yeah. Yeah, negative 2i times the square root of 2. Perfect. Thanks, Laura. Now, we've already done the square root of negative 12, right? That was just this right here. So I'm going to write this one as negative 9 plus 2i square root of 3. How about this one over here? Well, I guess what I'll do is I'll break that up into two square roots. I'll write negative the square root of negative 144 over the square root of 361. Notice that I kept the number of negative signs the same. In the numerator, I've got two negative signs, and I still have two negative signs. So altogether, I've got two negative signs. Now I'll help you out with the denominator. In the denominator, I'm going to get 19. But how about the numerator? What do you get when you take the square root of negative 144? Bjorny, any suggestions? Well, let's see. We're going to put a negative out in front. And, you know, I'll do a negative 1 here. 144. Go ahead, one more time. Yeah, so it's going to be negative 12 over 19. But negative 12 what? I. Yeah, negative 12I. There you go. Now maybe you can start kind of eyeballing some of these things and jumping right to the answer. What's going to happen with the square root of negative 16? What's that going to turn into? 4i. Well done. Thank you. 4i. And the thing that's going to happen next is we're going to start adding complex numbers. So you can add and subtract complex numbers. And then our big work in this section is going to be to divide complex numbers. So let's see. In adding complex numbers, you're going to add the real parts. So that's not a real big thing here. 7 plus 5 is going to be 12. And then you're going to add the imaginary parts. So what's 6 plus negative 2?
4i.
Yeah. So we'll end up with 12 plus 4i. And that's it. You're done. There will be a problem on the test to add and another one to subtract complex numbers. Please don't overdo them. I get it all the time. People want to treat it as if it's multiplication and you have to do something like this down here. That's not what we have up here. So please, if I give you an easy problem, keep it an easy problem. Right? I'm not trying to make them harder on you. Let's see. Let's do the same thing again here. And then down here. This time we've got to subtract complex numbers. But if you notice, I'm writing a little bit of extra stuff here because there's a step that I'd recommend you do before we combine our complex numbers, and that is let's distribute that negative sign to both of these terms. So it's going to be 2 plus 7i minus 6. And then what about the last term? What should that last term be?
Plus 5i.
Plus 5i. Nice. And now that you've gotten rid of the parentheses around these terms, we didn't need it around the first one. Now that we got rid of the parentheses, now we can combine like terms. Miguel, what's that going to be when we combine the like terms here, please? Minus 4. Keep going. Perfect. Minus 4 plus 12i. And if I want to feel really kind of, you know, like I'm giving you a slightly tougher problem, I can give you something like this, where you've got to figure out the complex numbers or the imaginary part in the first place and then combine them. So this one's yours. Give that one a shot. If you're watching this later, give yourself a minute or two to try and solve that as well. Okay, so we're going to do some of this stuff in our head. This is going to be 4 plus square root of 5 we've done a couple times here, right? That's going to be 5i minus 5 plus what? What's the square root of negative 9 going to turn into? 3i. Now let's distribute that negative. So it's going to be 4 plus 5i minus 5 minus 3i. So notice that it changed the sign on both of those terms. And now it's just a matter of playing, combined like terms. We've got 4 minus 5, and you've got a 5 minus 3. And when you combine these, Dave, what do we end up with?
You get a negative 1 plus 2i.
Yeah, negative 1 plus 2i. Well done. We okay with that one? Good. All right. Let's keep going. Now, where it gets a little bit tricky is when you multiply complex numbers. And there might be a part of you that says, oh, well, that's negative 4 times negative 81, that's 324, square root of which is going to be 18. That would be wrong. Those two things aren't equal. You have to simplify the square root part first. So how do we actually do that? Well, help me out. What's the square root of negative 4 going to be? What's the kind of quick answer on that one? 2i. Good. You're going to get 2i times, what's the other part of this? 9i. Now help me multiply this out. What's 2 times 9? 18. What's I times I? I squared. And probably the best thing to remember out of all of this is this stuff right here. I is the square root of negative 1, and I squared is negative 1. So there you go. I squared is going to turn into a negative 1. So overall, this turns into a negative 18. 18 times negative 1, or better yet, just negative 18. So if you're not careful, you'll end up with a positive 18 instead of a negative 18. Okay. Is that a question or? Okay. All right. I'm going to bust out another sheet of paper for this one. Let's do kind of a quick joke here, though. Let me see if I can't find it. Here we go. Come on, come on. We're waiting for the laughter. All right. Katie's got a smile. Laura's got a smile. Extra credit for both of you, even though you're not actually enrolled in the class. All right. And half of a smile from Owen, so good deal. Thank you. All right, that's clever. I thought that was kind of cool. Let's actually look at this problem and see what's going on with it. So, example D. You should expect to multiply complex numbers on the exam. And this is an example of just that. So, although it might be combining a little too much in one problem, let's see if we can't simplify these things. So, Madeline, what's the square root of negative 16 going to simplify to, please?
4i.
4i. Nice. Thank you so much. And let's see. Micaiah, what's square root of negative 64 going to simplify to? 8i. Thank you both. So now it's a matter of you're multiplying two binomials. Now, if that old acronym works for you, that's great. By the old acronym, I'm talking of FOIL. First, outside, inside, last. But whatever you think of, you're going to have to distribute the 1 to both terms and then distribute the minus 4i to both terms. So Anya, maybe you can help me out. Let's do the first terms. This times this gives me
1.
1. And then this times this,
8i.
negative 8i. Let's do the inside terms next. Minus
I.
negative 4i times 1.
4i.
And then finally, negative 4i times negative 8i. Plus 32. Good. I keep going. I times I is
I squared.
I squared. Yes, well done. I times I is I squared. I'm not going to be happy if you leave it like this. There's a little bit more that I want from you on this. So what else can I do here? Can you see any simplification?
-8 and -4.
All right, the -8 and the -4, absolutely. So I can combine like terms here. And what am I going to get? -12, good. So -12i. How about one other thing that we can do here? Nice. I squared is -1. -1 times positive 32 really gives you a -32. So -32. Great. I'm almost done. You know, if you left it here, I don't know. Team USA beat Team Canada in hockey yesterday. I'm still riding this awesome high. Might order a USA hockey jersey, wear it on Thursday, or wear it Wednesday, I guess. But in any case, I might let that go, but I'd really be happier if you combine these terms, right? 1 minus 32, those are like terms. You can combine them, and you'll end up with -31 minus 12i. And typically speaking, we write it as the real part first and the imaginary part second. Bless you. That's because there's lots of uses for this in physics and electronics. And the real part and the imaginary part have different meanings. So you want to keep those straight. So we traditionally write it the real part, then the imaginary part. Okay, how's that one looking? Looking all right with that one? Let's try another one.
You can just leave it like that? You don't have
Yeah,
to, like,
that's as far as you can go, because these aren't like terms. If this had an I, then I could
okay.
combine them, but it doesn't. So that's as far as we can go. Yeah, good question though. Thank you. You know, this one looks like a little bit of weak sauce, and I promise not to give you any easy ones on the exam. So let's practice something a little bit more challenging. So we'll add limb one here. Let's do 8 minus 3i times 4 plus, we'll do, how about 6i? Something like that. It's the same kind of deal here that it was just a minute ago. So it's first terms, outside terms, inside terms, last terms. So give that a shot. And try and clean it up. Remember what we did here. Okay, so same kind of deal as last time. First terms gives you a 32 plus 48i minus 12i. And then a minus times a plus gives you a minus. 3 times 6 gives you 18. I times I gives you I squared. Now there's a lot of simplification we can do here. It starts with these middle two terms. Those can combine. That's going to give me a 50i. No, pardon me, a 36i. Over here, I get some more simplification. What happens to the minus 18i squared?
Plus
Plus
18.
18?
Yep, that becomes a plus 18. So I'll put that in here. And last but not least, plus 18 and 32 can combine. What's my final answer here?
50 plus 36i.
Thank you so much. 50 plus 36i. Beautiful, beautiful. Let's do two more like this in terms of multiplication. Then we're going to work on division, and we'll finish up with powers of I. So as far as the one extra one for example D here still, let's look at 8 minus 4i squared. So, okay, a little different one on these. That's fine. Let's just kind of do this here. Now you can't take a shortcut on this. You can't go 8 squared is 64 minus 4i squared is, plus 16, etc. It just doesn't work. What are you going to have to do to multiply this out? Any suggestions there? And let me make this look like an actual 8 while I'm waiting for you guys to come up with a suggestion.
Can't you just write it out like you did for the last problem, like between each other?
Perfect. You're going to multiply it by itself. You're going to do 8 minus 4i times 8 minus 4i. And then do it all out. So that's going to be 64 minus 32i. And you actually get that term twice. Now in college algebra, I'll start talking about a tiny shortcut for these things, but for this class, just multiply it by itself, then clean things up. You can combine like terms here. We get 64 minus 64i. And Carmen, what's going to happen to that last term there?
Maybe 16.
Yeah, minus 16. And then we can combine that with our 64. So we end up with 48 minus 64i. Beautiful. Are you okay with this? Is this pretty straightforward, I'm hoping? Yes? No? Okay. Now I'll make a little deal with you, but you got to do your part as well. I'm going to show you a nice little trick, but I still want to see the work on your test. We can check this. We can know that we got it right before you ever hand in the test. You still got to show the work though, okay? All right with that? All right, so you can know if you got this right. Take out your calculators again. Let's clear out all of this stuff. Let's actually type in the problem. It's parenthesis 8 minus 4i. Where was the I term again? What'd you have to do to get that?
Blue button and then the period.
Blue button and then the decimal. Perfect. Right parenthesis and then the square key and booyah, there you go. 48 minus 64i. Nailed it. That's so cool. Yeah, Blake's happy. He's like, man, I'm glad I got a professor who's, in the modern world and not making us, do all these things by hand. You can check these things out. So that's pretty cool. And you got it right. Nailed it. Now, there's one other problem that is kind of interesting in this set, for example, D, and it's when you multiply conjugates here. Remember, that's what I said about these terms up here, 5 plus 6i, 5 minus 6i. I call them conjugates. Let's multiply conjugates down here. So 5 plus 3i times 5 minus 3i. So those are conjugates. Multiply those together, and you should see something interesting happen. So, and we're going to have to take note of that little interesting thing that happens there. You guys seen it? Is there something interesting that's happening in this one? Something different?
I got 34.
Got 34?
Yep.
So notice you start out with two complex numbers, right? Here's a complex number, here's another complex number. And when we multiply them together, I get 25. And Shane, maybe you can help me out here. What's the outside terms going to give me? Negative 15i. And the inside terms? Plus 15i. And how about the last term? Minus 9i squared. Beautiful. Now, what's the cool thing about this problem? What happened when we started doing this, multiplying it all out?
The eyes cancel out.
Yeah. The i's canceled out. And what happens with this term here?
Positive 9?
It's positive 9. So even though you started out with two complex numbers, you end up with a real number. Now, if you wanted to, you could write it as 34 plus 0i, but I'd probably prefer this. I don't really see any point to writing the 0i. I mean, either one is fine. But yeah, you get rid of the imaginary part. That's a cool little thing to keep in mind as we move into our, ooh, here's a fancy word for you, penultimate. Penultimate little subject here, next to last, and that is dividing complex numbers. But I think looking at your faces, you're cool with this one? Looking good there? All right. Let's take a look at dividing complex numbers. So, for example, we'll start out with example E. We've got 9 divided by 6 plus I. Now the problem with I, the reason that we don't like it in the denominator is because it's really a complex number. And a complex number has, as part of it, a square root. And mathematicians just don't like square roots in their denominators. So don't write this down, but it's really 9 over 6 plus the square root of negative 1. By the way, I've never ever really seen a place where you go backwards, where you replace I by the square root of negative 1. It's always this way, never this way. But we don't like that square root of negative 1 in the denominator, so we're going to get rid of it from the denominator. This isn't an equation, though. So I can't multiply both sides by something, but I can, Bjorny, multiply by 1. So, let's think. Now, I got to multiply by 1 in a clever way. So it's going to be something over itself is going to give me 1. But any suggestions? What's going to help me out over here so that I can get rid of my complex number in the denominator? Close. Go ahead.
6 minus I.
Yeah, 6 minus I. It's conjugate, remember? Right back here in the last problem, the big thing to notice is that when we multiply conjugates together, you get a real number. you get rid of the imaginary part. And that's what our goal is for this one, is to get rid of the imaginary part. 6 minus I, 6 minus I. And let's see. Sometimes I hold off on distributing, so I'm going to leave it as 9 times 6 minus I in the numerator. But in the denominator, I'll get 36 minus 6I plus 6I minus I squared. Now that looks like a big mess, at least for the moment. But it's not too bad. Tomorrow, is there any simplification in the denominator? Yeah, the I terms cancel out. Is there any more simplification? Anyone else?
The I squared cancels out?
What becomes of I squared?
Oh, 1.
Yeah, this minus I squared term becomes minus 1, or I think you cut right to the chase, plus 1, right? So we'll end up with,
37.
yep, 36 plus 1, or 37. Now, the reason I didn't distribute the 9 is because sometimes you get a little extra cancellation here. But 9 doesn't go into 37 easily, does it? So you could either leave it like this, or you could distribute it out. 54 minus 9I over 37. Sadly enough, WebAssign sometimes wants things in the form of a real number and a complex number, a real part and a complex part. And to get there, you're going to have to write this as 54 over 37 minus 9 over 37 times I. So that would be your real part and imaginary part. And I'm thinking that WebAssign, 2Bs, no, 1Bs. WebAssign is going to probably prefer it like that. I think they want your real part and imaginary part done up separately. So just giving you a heads up on that. For myself, I'm a little bit more generous of spirit. I'll take any of these. We'll put a smile on my face. I'll be happy to see any of them. All of them are right. In fact, here's some incentive for you. Want to earn 1 point on this without doing any other work? You start by multiplying by the conjugate. All right? That's worth 1 point of partial credit right there. If you recognize, oh, I got to multiply by 1 in the form of the conjugate over itself, that's 1 point right there, even if you did nothing else. So try and get that 1 point. Now, of course, they don't always stay quite that easy. So you're going to get problems like the next one here. Questions on this before I move on to the next one? So the next one looks like this. 2 plus 3i over 2 minus 3i. Wow. Okay. Well, I'm going to start out by multiplying by 1 again. And I guess I like this example because people get a little confused with what to multiply by, but it's the same thing as we did with the last one. So, Dave, what do you think I should be multiplying by? What over what in this case? Nice. It's always going to be based off the denominator, 2 plus 3i, and I have to have the same thing in the numerator. So 2 plus 3i over 2 plus 3i. Even though I've got a 2 plus 3i already in the numerator. That's okay. Don't change this. This has to equal 1 in order for this to work. So you're going to have to FOIL in the numerator and FOIL in the denominator. Lots of FOIL, FOIL, FOIL everywhere. So let's have some fun and FOIL this one out. let's see how things are looking. We'll start with the denominator. Bjorny, help me out. What am I going to get in the denominator when I multiply this out? 4, and then what? Plus 6i
Minus 6i.
minus 6i. Good. And then how about the last terms? Thank you. Well done. Minus 9i squared. So, okay. In the numerator, it turns out to be pretty much the same. It's just that we get 4 plus 6i plus 6i minus or plus 9i squared. So in the numerator, you're not going to get the 6i's to cancel each other out. Instead, you'll get 12i. In fact, you're going to get 4 plus 12i minus 9 over, well, let's do some cancellation here. 6i and 6i, those cancel out. What about the minus 9i squared term? Blake, how's that one simplify?
It's gonna be plus 9.
Yeah, so 4 plus 9 gives me 13. Thanks, Blake. And 4 minus 9 gives me minus 5 plus 12i. And like I said, I'll be happy with this. WebAssign might prefer negative 5 plus, or negative 5/13 plus 12/13 times I. So again, that's WebAssign. But I'll be happy with either of those. You can check these on your graphing calculator. Takes a tiny bit more finesse, but if you put those in, you can't use the horizontal fraction key. I don't think it'll work. But if you put it in like this, there you go. You checked your answer. Feeling pretty convinced? Probably not. You shouldn't. Because we ended up with something that looked like this. But here's the trick on this one. And again, I want to see the work on the exam. All right, but you can check your answer. Hit the math key and answer the fraction. Booyah, there it is. Negative 5/13 plus 12/13 I. Exactly like what we got. All right. Now this is a good 6 or 7 point problem on an exam. So it's a good idea to make sure you got it right before you hand it in. And I'm telling you how to check it. Now, if this is all you give me, I'm not going to give you a lot back in return for credit on that one. All right. But you know what to do here. You're going to multiply by 1, show me the work. You can stop here. That's fine. Nothing wrong with writing it like that either.
So what do you press again? Math?
So once you do the division part, then you press the math key and then you press enter twice. It converts your answers to fractions. So for instance, I've already got it as a fraction, so I can convert it to decimals. I'll get this really ugly thing again, but then I can convert it back to fractions. So yeah, it's pretty nice. Do you want to do one more practice for division, or are you comfortable with division? It's up to you. Whatever works for you. One more? One more? The last row is different stuff.
No, the last one is
The last one here? Okay, sure. So there's a little bit of tiny extra work we got to do for the last one. Maybe you can start out. Now, if I'm going to write it here, what do you think I'm going to start out with for the last one? Any suggestions? 6i, good. And 2i. Nice. All right. Let's have at it. So it's going to be 3 plus 6i over 1 plus 2i. Bless you. Miguel, what should I multiply by in this case?
1 minus 2i.
Yeah, in both the numerator and denominator, you're going to multiply by this conjugate. So it's going to be 1 minus 2i, 1 minus 2i, plus u squared. And work it all out. You should be interestingly surprised on this one, and we'll go back and take a look at this again to try and understand what's happening. David, did it simplify pretty nice?
So far, yeah.
So far, yeah? Okay. Well, that's cool. We'll try and understand why it simplifies so nicely. Someone help me out with the numerator. What do I get in the numerator? 3 minus 6i plus 6i. Keep going. Nice. 3 minus 6i plus 6i minus 12i squared. Again, lots of nice simplification here, right? In fact, we get simplification in the denominator, which we expected. But we get some bonus simplification, right? The numerator simplifies. So it simplifies down to 3 plus 12 over 1 plus 4. Or how about 15 over 5? I think I'd be unhappy if you left it like this, though. What do you think I expect?
3.
Yeah, I expect a 3. And that's your answer. Is there a quicker way to do that one? I think so. Did you see it, Carmen?
I don't know if this is it, but they're both the same because
Ah.
I feel like
If you
one has-
if you factored out the 3 from the numerator, you get this, right? Now I can't cancel the 2 into the 6 and then 1 into the 3, and I get 3 plus 3, that'd be 6. But once I factor out the GCF, now I've got this times this in the numerator and a 1 times this in the denominator. Basically, I can cancel this out. I'm just left with 3 over 1, which of course is 3. So nice. It's kind of a nice one there. Nice. Now there's actually 4 different things that can happen when you raise I to some power. Those 4 things are I to the first power is I. What's I squared going to give you? I cubed give you -1. I squared give you -1. I cubed, well, that's just one more I here. So this times I gives me I cubed. -1 times I gives me -I. How about I to the 4th power? That's I squared times I squared gives me I to the 4th, which on the right-hand side would be -1 times -1. -1 times -1 would be +1. So when you raise I to a power, those are the only things you're going to get. You're going to get one of those 4. Now, I used to teach it to people that you would memorize these things and then figure out things by powers of 4. But there's a nicer way to do this. This is the only thing you've got to remember, is that I squared is -1. Now, when you look at I to the 22, you might say, well, how does that help me? Well, I to the 22 is really I squared to some power. Now, what power should I put out here? 11. Because 11 times 2 is 22. You okay with that? So I just rewrote it, but I rewrote it using I squared. Now, how does that help me? Can someone tell me what I squared is? -1. Now, -1 to the 11th power means -1 to -1 to -1, etc. But the important thing is that I've got an odd number of these. So if I have an odd number of them, I end up with a negative. So I end up with -1 in that case. Let's try that again over here. And again, I'm going to start out with I squared to some power. What power is it going to be this time? What times 2 gives me 32?
16.
Yeah, 16. Laura, let's simplify the inside here. I squared is?
-1.
Well done. Now this time I got -1 to an even power. What's -1 to an even power going to be?
1.
+1. Beautiful. Beautiful. But I don't have to stick to just nice even powers of I. What if I had an odd power of I? With your odd powers of I, there's an extra little trick here involved. So let's take a look at I to the 57. I to the 57 is very close to a nice even power of I. I to the 57 is close to I to the 56. But I can't just throw away one of the i's, so I'll write it as I to the 56 times I. Remember what happens when you multiply things with the same base. Dave, it's not really written, but it's understood that this power of I here is a what? 1. And when you multiply things with the same base, you add their exponents, right? So 56 plus 1 gives me 57. So this and this are the same. But here's the trick. I'm just going to play around with this part and ignore this part. So I'm going to rewrite this as I squared, again to some power, times I. Now the question that you have to answer for yourself is, what do I multiply by 2 to get 56? 28. Finish simplifying it up. You're never going to lose track of that I. That I is just going to stay out and back. So this is going to become -1 to the 28th. Anya, -1 to the 28th power. What's going to happen to that term? Yeah, positive what? Yeah, so I'm just going to end up with 1 times I, or better yet, just I. Nice. But notice the only thing we have to memorize in this is I squared. I squared is -1. Okay, let's try a couple more here. How about, yeah, please do. Yeah, what do you got?
We put 1 for that answer, would that be wrong?
If you put 1 I, I'd be
Because I to the first power equals 1.
but you can't get rid of the I. It's not, your answer is just going to be either 1 I or I. Either one of those two. But we can't lose the I altogether, but you can lose track, you can lose the 1. You don't have to write the 1. All right, appreciate that. Let's see. Let's take a look at I to the 83rd. We're going to start the same way we did with the last one. 83 is an odd number. I can't do this game with odd numbers. So how should I rewrite this to begin with? I to the what times what? Go ahead, David.
82.
82 times I to the first power. Beautiful. Finish that up. See if you can't do the same thing there that you did with this one down here. please, please. First thing we did was we broke this up as I squared times something. I squared 2 to something. And do the same thing here. I squared 2 somehow. And the trick is, 2 times 28 gave you 56. You can do the same thing there with 82.
Where we got, I've got negative 1 times
Oh.
I.
Which is just negative I.
Okay.
Yeah. Sorry, I didn't see all that.
It's kind of a mess.
That's all right. No, look carefully on this. Yeah, I got it. We write it I squared 2 times 82 would be 164.
Yeah. Yeah. Just-
It's okay. It's all right. See, it's painless to make these mistakes now, because it doesn't
I
hurt
was
you.
rewriting the 57 on here for notes.
Okay, just so you know, on the test, I want to see some work. And I know that's the right answer, but I need to see the steps.
In 1 step at a time.
I still need to see the steps, because I've shown you how to do this stuff. I need to see steps like I'm doing here. Okay. Because I know that everyone can do these things on a calculator. And there's a downside. The calculator doesn't always give you exactly what you expect. Okay, so I want to be clear about these things. I've shown you repeatedly how to check your answers on a calculator, and that's fine. I want you to do well. I want you to get the right answer. But I still need to see the work. So this becomes I squared raised to the 41st power, because 2 times 41 gives me 82 times I. So that's negative 1 to the 41st power times I. Negative 1 to the 41st is just negative 1. You're raising to an odd power. So negative I or negative 1. And that's great. Now you can check these things on your calculator. That's fine. I know that. That's why I want to see the work. And one more comment here. It doesn't always work when you're checking yourself on the calculator. So for instance, what if I did I to the 732? I can still do that, by hand. It's a little bit of a pain. You might look at that and go, oh, wait a minute, I don't get it. But what I'm going to start out with is, well, this is going to be I squared, and I'm not leaving myself a whole lot of room here. I squared raised to the 366 power. I squared is negative 1. I've got negative 1 to an even power. What does negative 1 to an even power give me? Do we get positive 1 or negative 1?
Positive 1.
Positive 1. So I get this. But what if I put that into my calculator? If I'm like, yeah, I'm just going to put that in my calculator. And I get this. What on earth is that? Doesn't look like what I just got, does it? Now you can actually make sense of this, but I'm just going to use it as a cautionary tale. It's like, okay, you should understand this process. I want you to be able to do it this way. I have no problem with you checking it. just make sure that you can do it showing me this. Or there's another method that you can use if you want to remember these and divide by 4, that kind of thing. But mostly I expect this. All right. Comments on this last one? Yay, all done.